Welcome back, everybody. I hope everyone had a good weekend and a good first week of class. So we'll pick up where we left off in 1.1 and then move on to 1.2. Regards to this, if you didn't finish your AI, so the AI assignment was technically due on Sunday, but since it was the first week, I'm willing to kind of be a little lenient on it. So if you missed it, just email me and I'll give you an extension for that first week just because it's weird. As a reminder, our syllabus quiz is due this Wednesday by 2 p.m. If you don't finish it by then, I have to mark you as not participating, which drops you from the course. So please get that done if you haven't done so already. And we'll have a grand old time. So continue where we left off. The vertices of a rectangle are positioned at -3, 0, 0, -3, 1, 4, and 4, 1. So just some fun practice. Let's go ahead and plot those points. This is -3, 0. That's right there. 0, -3 is right there. 1, 4 is right there. And 4, 1 is right there. So we're trying to find the area of that rectangle. So, and I'll even label the points if I'd want. 1, 4, 4, 1, 0, -3, and -3, 0. It says find the area of the rectangle. This is a good question to think about. Critical thinking here. Okay, I need to find the area of the rectangle. How do I find the area of a rectangle? I need the length and the width. So I need to know the distance between two vertices and another set of two vertices. So you could either do, like, you can do this in a million different ways. You could find this distance here and this distance here, or you could do this distance and this distance. There's 80 million ways, like not 80 million, 4 different ways. So it doesn't really matter which one you do. I'm going to decide to use I'm going to use these two here. I'm going to do this one and this one. So I'll call this L and this W. So L for the length is equal to the distance between those 2 points. So the distance formula, if you remember from last time, x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared, square rooted. So that's going to be 1 minus -3 quantity squared plus 4 minus 0 quantity squared, which is the square root of 32. And by the way, if you want to get to the point where you feel comfortable making that just a plus, I'd encourage that. When you subtract a negative, you're adding it, so that's fine, however you want to do it. W, on the other hand, will be the square root of 0 minus -3, so 0 plus 3 squared plus -3 minus 0 squared. That's going to be the square root of 9 plus 9, so that's the square root of 18. So that's the length and the width. The length is square root 32 units. The width is square root 18 units. So I guess technically meters, because it says assume that the unit of measurement is meters. So then the area of the rectangle will be length times width, which will be the square root of 32 times the square root of 18, which is 24 when you plug it in your calculator, meters squared. I thought it was a cute problem. Fun one. Cutesy. All right. Any questions on that problem? Hopefully you were able to do that with your friends this weekend. It was probably a good bonding experience, good thing to do. Who needs Mario Kart when you got mathematics, right? So, connections between graphs and equations. So definition 1.1.1. A solution to a two-variable equation is an ordered pair x comma y that forms a true statement when inputted into the equation. So for example, For the equation x squared minus y squared equals 4, the ordered pairs negative 2 comma 0 and square root of 20 comma 4 are solutions, but 5 comma 3 is not. As I did one here, I replaced the x's with that I saw with a negative 2 and the y's with a 0. Negative 2 quantity squared minus 0 squared is 4. 4 equals 4. Good. Checking the next one. So square root 20 quantity squared minus 4 quantity squared. Does that equal 4? That's going to be 20 minus 16. That's going to be 4. So 4 equals 4. Yes, it does. But 5 comma 3 is not a solution because when I plug it in, I'm not going to get a tautology. I'm not going to get a true statement. But let's just verify it. 5 squared minus 3 squared, does that equal 4? That's 25 minus 9, that's 16. And 16 does not equal 4, so it is not a solution. That's how we determine whether or not things are solutions to an equation, to a two-variable equation. It has to solve, it has to make a true statement when it gets plugged in. And so, since they are order pairs, that means they represent points in the coordinate plane. And so the fact of the matter is that the solutions of an equation create the corresponding graph. As such, we can find solutions. Hopefully we can, but we can find solutions and use them to graph, them to sketch. Graph. So because the solutions are ordered pairs, they create graphs in the coordinate plane. And so if we don't know what the equation is off the top of our, by just looking at it, there are certain things in mathematics where you start to look at it and you know exactly what it is. In Math 127, you'll start talking about ellipses and hyperbolas and maybe parabolas in a different context than we'll be going over, and circles. And then from there, you can, like, those are common equations that we know what they look like. But most of the time, you don't know what the equation will look like. So you find solutions and then use that to sketch it kind of by like connecting the dots. So below is the graphical representation of the line y equals 3 halves x minus 1, and you can verify it for yourself, but all the points listed on are solutions to that equation. In fact, there are infinitely many, uncountably infinitely many, but all these points, if you plug them in, you will, I guarantee you will get a solution to this equation. So that's one way we can do these things. So we can find several solutions to the equation y equals x squared minus 3 and use them to make a rough sketch of the corresponding graph. Now, because because it's a two-variable equation, we can just pick one variable, pick one value for one of the variables and solve for the corresponding variable. So, for example, I'm just going to choose -2, -1, 0, 1, and 2. And plug it into the equation and see what y will be. So I plug in -2 into the equation, I'll get -2 squared minus 3, that'll be 4 minus 3, that's 1. So we have the point -2 comma 1. Doing it for -1, you'll get -1 squared minus 3, that'll be -2. So we have the point -1 comma -2. It's always x comma y. Similarly, if you use the other ones, you'll get 0 comma -3, 1 comma -2, and 2 comma 1. So like that. And you plug in x value of 2, you'll get 1. So we have those 5 points, and we'll plot them. So -2 comma 1 is right there. -1 comma -2 is right there. 0 comma 3 is right there. 1 comma -2 is right there. And then 2 comma 1 is right there. And so we could plot more if we wanted to. We could keep going, but you'll see if you do that, it just keeps getting larger and more up in each direction. So we can generally assume that the overall shape should look something like this. We've drawn our first parabola for the course. We'll talk more about parabolas in Unit 2, but you can utilize points to graph a to make a graph. Okay. Long day. Is it over yet? Is it time? Is it nap time? Please. Okay. So next are intercepts. So given the graph of a curve, wherever it may be, an x-intercept is a point a comma 0 where the graph intersects the x-axis. Similarly, a y-intercept is a point 0 comma b where the graph intersects the y-axis. A comma 0, like, so the key thing here I want to mention is that technically speaking, an intercept is an ordered pair. I believe on Alex, unless they've changed it, Alex wants you to write it as just the x coordinate or the y coordinate for the x intercepts or y intercepts respectively. So they just want you to write the x value or the y value, which is not technically correct, but either way. If it comes to my exams, I will be very, very particular. I'll say like write the x-intercept, and I'll like in bold italics, I'll write the answer as a coordinate point to make sure that I want it as the coordinate point. Or if I don't specify, then you can write it in either way. That being said, if you write it on Alex if you write the x-intercept as a point and it wants it as just the value, it'll mark you wrong. Just email me and I'll give you full credit back. Because I don't really think there's a big difference between either one. So as it says in the note, sometimes it's accepted, just write the x value. So instead of writing 4 comma 0, that Alex might want you to write just 4. But either way, so we can find them graphically. That one's the quick one. So x-intercepts. This example. -6. Yeah.
Sorry to interrupt. A few people had questions over there. If you were raising their hands, I didn't want to like.
Oh, sorry. Thank you. Thank you for letting me know. I didn't see. That's supposed to say a comma 0, but it doesn't really look like an a. Thank you for calling me out on it. And then the other one's supposed to be b 0 comma b. Thank you. Thank you. So the x-intercept would be -6 comma 0. Or just -6, depending on the situation. Does someone have a question? Another question? So I like to see it as a point, but I know Alex can be a little bit particular. So either way is fine. It just depends on the context in which you want to mention it. The y-intercept would across the y-axis, which would be precisely here at 1. So that would be 0 comma 1 or just 1, depending on the situation. Now, curves can have multiple x-intercepts or multiple y-intercepts. It all depends. This one here, it starts and ends right there, but I could make this go infinitely in a spiral. And it would be all fun, but let's list the x-intercepts. So I'll use red. -6, -2, 0, and 4. So we could list them that way. So -6 comma 0, -2 comma 0, 0 comma 0, and 4 comma 0. Or you could just write -6, -2, 0, and 4. However you want to write it is fine. Like I'll make sure to write in bold italics if I want you to write it as an ordered pair. Y-intercepts, similar situation. -7, -3, 0, 1, and 5. So 0, -7, 0, -3, 0, 0, 0, 1, and 0, 5, or you could write it as -7, -3, 0, 1, and 5. Terrible or. Whichever way works. Finding them graphically is fun. It's fun stuff. The reason why I like to write them as coordinate points is because it really highlights an important feature of it. As I said earlier, the graphs of equations are particularly the places that make them true. And so when it comes to trying to find them algebraically, you know what one of the coordinates will be. For an x-intercept, it's where it crosses the x-axis, and that's precisely where y is equal to 0. And y-intercept where it crosses the y-axis, which is precisely where x is equal to 0. So if you're not given a graph, you can still find the x-intercepts and y-intercepts. For x-intercepts, you're going to set y equal to 0 and solve for x. And for y-intercepts, you're going to set x equal to 0 and solve for y. So for example, if we have this example here, (13x minus y over 2 minus 15). So if I want to find the x-intercept, I'll set the opposite variable equal to 0. So for the x-int, y equals 0 would tell me that I would get 13x minus 0 minus 15 is equal to 0. That should give me x is equal to 15/3. Fractions are people just like you and me. We don't need to be afraid of them. So we have the x-intercept 15/3, 15/13, excuse me, comma 0. And for the y-intercept, we'll set x equal to 0 and solve for y. So we get 0 minus y over 2 minus 15 is equal to 0. That would give me negative y over 2 is equal to 15, which I would then multiply both sides by -2 to get me y is equal to -30. So 0, -30. Or once again, just -30 if you want to write it as just the y coordinate. Sorry, I'm going quick because I want to get to the next section if possible. As soon as possible. Any questions on that?
Oh, never mind. I didn't see the negative sign. Like, wait, isn't that supposed to be negative?
Yes, that's a very, very tiny negative sign. All right. Go ahead and solve for the x-intercepts and y-intercepts of this one. I'll slowly fill in details. Okay. I did that quickly though. I don't expect you to be as fast as I am. While people are finishing up. Got something really exciting to show you guys, by the way. So I went to my son's preschool to drop him off, and one of the girls there showed me some new math not discovered ever before, and she gave it to me. So this is some new math for you guys. Look at this. Yeah, studying it, green then pink. Depending on the situation, pink then green. It's gonna be on the exam, so please, new math, really cool. She basically all but told me that I had to show it to my class. So how could I say no to a 4-year-old? Um, very, very sweet girl. Anywho, I promised her that I would show it to all my classes. So there we go. Promise fulfilled. So setting for the x-intercept, you're going to set y equal to 0. So that'll just wipe out the minus y portion. So you get x squared plus 3x equals 10. Bring everything to one side so that you can factor and solve. X squared plus 3x minus 10 is x plus 5 times x minus 2. And therefore, you get the solutions to that would be x equals -5 and 2. So our x-intercepts are -5, 0 and 2, 0. And similarly for the y-intercept, but we don't need to factor it all because it's not a quadratic. So we're all good. Any questions on that? That factoring should feel like second nature. If it doesn't, then you need to practice your factoring because we're going to be doing a lot of that in this course. So please make sure your factoring skills are on point. If you have any questions about it, feel free to ask me. I'm happy to point you in the right direction for some videos to practice factoring. One more problem. Find the x and y-intercepts of this, an absolute value equation. Yay. Haven't really dealt with those in a while, but let's do it together because this one's a little bit weird if you haven't seen absolute values in a while. So for the x-intercepts, we're going to set y equal to 0. That is, we've got 0 equals the absolute value of 3x minus 2 minus 5. And so we've got to solve that. And what we do is we bring the 5 over. We get absolute value of 3x minus 2 is equal to 5. And so with absolute value equations, the inside could either equal 5 or it could equal -5. Because if the inside, ignoring the absolute value sign for a second, if 3x minus 2 equaled -5, when you take the absolute value, it would give you +5. So there's two different situations. Either 3x minus 2 is equal to 5, or 3x minus 2 is equal to -5. Adding 2, you get 3x equals 7, which because x equals 7/3. Adding 2 in the other situation, you get 3x is equal to -3, so x is equal to -1. Those are our x-intercepts, 7/3, 0, and -1, 0. And our y-intercepts, we haven't done yet. Set x equal to 0, you get y equals absolute value of 0 minus 2 minus 5. That'll be 2 minus 5, which will be -3. So 0, -3. I'm sorry to rush. I'm not trying to rush. Just trying to get caught up. I took too long last time. And it truly is okay if you do have questions, by the way. You have a question? Last one is just a kind of an observational one. It's saying, what are the x and y-intercepts of this equation or this graph? None. It doesn't have any. It doesn't cross the x-axis, and it doesn't cross the y-axis, so it doesn't have any. That happens sometimes. Sometimes not all graphs have x-intercepts and y-intercepts. It's always randomized. So, okay. Now we'll move on to unit 2, 1.2, which is on circles. Kind of a random jump honestly, but this is just how we roll here in 126. In order to get to where I want to talk about with circles, we need to talk about completing the square. Do you remember what that is? It's okay if you don't. We're going to go through the process here. So, sometimes in mathematics, it's useful to change quadratic equations or quadratic expressions from standard form, which is ax squared plus bx plus c, to vertex form, which we'll talk about more when we get to unit 2. But vertex form is a times x minus h quantity squared plus k. That a is the same a, by the way. It's not a magic new a. It's like you can convert any standard form to vertex form and from vertex form backwards as well. And this process is called completing the square. So if you want to go to standard form, you're like 3x squared minus 18x plus 25. The vertex form of that is 3 times the quantity x minus 3 squared minus 2. So how do we go about doing that? So if you're trying to complete the square, there are 2 different cases. Case 1 is the nicer case, where the leading coefficient is 1. Before I continue, I do this differently than the way the textbook teaches it. And a lot of teachers will teach it by adding the same number to both sides. When it comes to talking about circles and how to find the centers, they'll probably explain it by adding a number to both sides, which I disagree with purely because this is a good setup for unit 2 once we get there. And there's going to be many more opportunities in calculus and beyond where completing the square is a much better option to do than the way that they do it with circles in this section. So I'm going to show it my way, but if you like to do it a different way, that's fine too. So step 1 is darn it. How do I want to write it? I did not grab a copy of my notes, so I don't remember what I said here. Like I know exactly what I want to say, but I wanted to say it perfectly. So how do I want to do this? I'll just go to my old copy of it and copy the statement. Sorry, I forgot to print off the copy of this. Apologies. There we go. That's what I wanted to identify. There we go. Let's use freeform actually. Grab this. And this. Apologies, everybody. Huzzah. All right. Step 1 is going to be identify the b term and calculate b over 2 squared. So for us, in this example, b is 10. So that means that b divided by 2 squared would be 10 divided by 2 squared, which is 5 squared, which is 25. All right, I'm going to rewrite that. So that's 5 squared, which is 25. We're going to identify the b term and calculate b squared or b over 2 quantity squared. Now, like ideally, you're doing this algebra in your head or this arithmetic in your head. 10 divided by 2, that's 5 squared, 25. But I deliberately wrote it down in all those steps here for a reason once we see in step 2. That's step 1 is to find the b term, calculate it, calculate b over 2 quantity squared. Then what you're going to do, once you've done that, either jot it down on paper or keep it in your brain, you're going to add and subtract that. So in this case, 25, you're going to add and subtract that right after the b term, the bx term. This is going to make a perfect square trinomial. So in the process, what we've got, I'll let you write that down because I didn't write it down this time. So add and subtract b over 2 quantity squared after the bx term, and this will make us a perfect square trinomial, and therefore completing the square. So we've got this x squared plus 10x minus 8. We're going to add and subtract 25 right after the 10x. So x squared plus 10x plus 25 minus 25. And then stop on your minus 8 and don't forget it. Like SpongeBob when he's describing how to do this to blow the bubbles, right? Stop on your right foot, don't forget it. Remember that? We all SpongeBob people here. Love that one. Patrick laughs and says this is a giraffe when it's an elephant. It's great. Classic humor. The answer is why. Why did I do this? Why is this? This is what I like to call cleverly adding zero. You'd be surprised how many proofs in mathematics, how many theorems, how many things that we do rely on this little trick. Mathematicians love doing this trick, adding zero by adding a number and then immediately subtracting it, or adding a quantity and immediately subtracting it. In calculus, the proof of the product rule hinges upon cleverly adding zero. In upper division mathematics, I'm blanking on one of them at the moment, but there's plenty of situations, and it's going to be used a lot in your mathematical career. So it's useful to get to know it. Add a number and then immediately subtracting it. The reason we did that is that this right here is a perfect square trinomial. This is x plus 5 quantity squared. Simplify. So we've got that this will be equal to x plus 5 quantity squared minus 32. And that's it in vertex form. Now, as a note, unless there's any questions on what I did. Yes.
I think it's 33 minus 33.
Indeed it is. Indeed it is. I was testing you guys. I swear I can do basic math. I swear. Every once in a while. I've been making sandwiches my entire life. Sometimes I still screw up my sandwiches. Same thing. Thank you. Catching them. 33. Indeed. So one thing to note about this is, yes, you could go through and do the factoring techniques, AC method, bottoms up method, whatever you want to do to figure out that x squared plus 10x plus 25 is equal to x plus 5 quantity squared. You could totally do that. Totally valid. Good way to do things. Good practice with factoring. However, if you want the quick trick, notice that this will always be b over 2. b over 2 in this case was 10 over 2, which was positive 5. And it just so happens that this was x plus 5. That's not a fluke. That always happens. So you can go through and factor it by hand, but you don't have to. You can just know that it's going to be b over 2. However you want to factor it, do that process is your prerogative. So let's do an example. Unless there's any questions on that. Okay. So this is one that is in case 1. The leading term, the leading coefficient is 1. So take the b term, half it. But you're thinking, Phil, no, that's a fraction. Yeah, what of it? I don't like dealing with fractions. Well, I don't like dealing with you then. Fractions are good numbers. They're good friends in life. So b over 2 squared would be 7 over 2 squared, which is 49 halves. We're allowed to calculate in this course. Be comfortable with it. So x squared plus 7x. After the bx term, add your b over 2 quantity squared and subtract it immediately afterwards. So plus 49 halves minus 49 halves minus 18. Oh. And so this is the reason why I recommend knowing that trick. Yes. 49 fourths, 49 fourths. Oh my God. Sorry, guys. It's been a long day. Phil, it's only 1 o'clock. I know. 49 fourths. Thank you very much. Yes.
What's on the left side is B over what? Oh,
That's clearly a 2. You guys can clearly see that's a 2, right? No. Fair enough. Fair. Thank you for calling me out. All right. Let's get that good. Cool. So this is the reason why I recommend that little note in pink, is that trying to figure out how to factor this one doesn't seem very fun to me. I could do it, but it wouldn't be very fun. So let's make it fun by recognizing that this is just going to be the factorization. This portion will just be x plus 7 halves. It's always the b over 2. Always b over 2. X plus 7 halves squared. And so at the end of the day, we've got x plus 7 halves squared minus, and I don't want to do that fraction in my head, so 49 over 4 minus 18. If you bought my calculator that I recommend, the calculators that I recommend, they actually are able to convert it to nice fractions for you. That will be, that would be negative 121 over 4. That. So, yeah, we can deal with fractions. All right. But what if the coefficient isn't 1? What if the coefficient is something like negative 7 or 33? What do we do then? So that's the next case. Step 1 is to get it into case 1. So step 1 is going to be factor out A from first 2 terms. Ideally, it works out. Ideally, it factors out from both of them. Ideally, it does. Every once in a while, it won't, but hopefully. So for example, in this one, 3x squared and 24x, they both have a common factor of 3, so we can do that. But don't worry about the C term. Don't worry about that. That's fine. I mean, you can, but very, very rarely will it be nice and neat. And so in this example, factor out A. So we got 3x squared minus 24x plus 5. We're going to factor out that 3 from the first 2 terms. That'll be 3 times in parentheses, x squared minus 8x, and parentheses, and then don't forget about that, plus 5. Why have I done that? Why? My son's favorite question.
It's easier to work with.
Mm-hmm. Now, on the inside, now we're in case 1. So we can just follow the procedure that we had from step 1. Complete the square on the inside. That's what step 2 is going to be. Complete the square on inside parentheses, inside of parentheses. So I'm going to write it what I had above, 3 times the quantity x squared minus 8x plus 5, and parentheses then plus 5, excuse me. So we got 3 times parentheses x squared minus 8x plus 5. And so I'm going to complete the square on the inside of the parentheses. And yes, this process does take a little bit more work and more algebra skill, but it's a good thing for us to do. It makes us stronger mathematicians. So we're just going to be better than the rest of the 126 classes, are we? So on the inside, the B term is -8, half the B term. B is equal to -8. So B over 2 squared would be -4 squared, which is 16. I'm writing this in blue. This is for our notes taking purposes, but if you were to do this on an exam or something like that, you could skip writing that and just do that in your head if you felt comfortable. It's just mainly meant for our note taking purposes. So this will be 3 times parentheses x squared minus 8x. Then we're going to add and subtract the b term, like the b over 2 squared. So add 16, subtract 16. Always add and then subtract in this context. And then don't forget about your plus 5 on the outside. This has created a perfect square trinomial. In particular, it's going to be x plus our b term. Our b term, or sorry, b over 2. And our b over 2 is -4. So this should become 3 times in parentheses, bigger parentheses, and then smaller parentheses, x minus 4 quantity squared minus 16, and parentheses, and then plus the 5. Skip as much arithmetic and algebra as you'd like. Because that's what step 3 is going to be, is simplify. Simplify by distribution. So in this example, I'm going to rewrite what I like the last thing I had. So this statement right here, 3 times that. So leave a little space. So 3 times in parentheses, smaller parentheses, x minus 4 quantity squared minus 16, and big parentheses plus 5. Let you write that down before doing it. We're going to distribute that 3 throughout to the 2 terms inside the big parentheses. Right there and right there, which gives me 3 times the quantity x minus 4 squared minus 48 plus 5, which gives us our final answer of 3 times x minus 4 quantity squared minus 43. So instead of trying to ideally, hopefully you see how this works. So how instead of trying to memorize 2 different procedures, understand how the first one worked. It was just adding and subtracting half the b term. And if you'd like to know why that's what happens, why that's the technique, I'm happy to show you. Just in the interest of time, I'm going to skip that, but I'm happy to show you at some point if you'd like. And then realize that case 2 is just case 1, but you have to work inside something. So instead of that's exactly what step 1 was for this. It was trying to convert it to a case 1 case. Any questions on that? It's okay if there are some. Yes.
You said this is like your way of doing it?
Yes, this is my way.
I remember, I did this before. It's like a traditional way. Is that the way that the textbook does?
Where you add it to both sides? Yes, yes.
Okay.
That is the way to do it when you're given an equation. But this is a lot so the way that they teach it in the textbook is if you have an equation to work with. But if you don't have an equation, you can't add to both sides because there's only one side. And so that's why I like this method more, which will be more relevant when it comes to functions, when we talk about trying to find vertex form for a quadratic. So, and then in math 181 and 182, possibly 181, you'll do this method a lot more. So, but once again, if you like to do the other way, that's fine. It's totally valid here. So go ahead and work through this one. I'm going to slowly fill in details. Feel free to talk to your neighbors too. They won't bite. Answer up here if you'd like to check your work. If you're still working on it, totally understandable. You should get -2 times the quantity x minus 3 squared plus 13. If anybody doesn't get that, that's okay. We can work through it. So factoring out -2, remember when you factor out a negative, it changes the sign of everything on the inside. So that -2x squared becomes a positive x squared. That plus 12x now becomes a minus 6x. And half of 6 is 3 squared. Half of -6 is -3. Squared it. It's positive 9. Add 9, subtract 9. So that's where I get the perfect square trinomial x minus 3 squared. And then I distribute the -2 throughout. I get -2 times the quantity x minus 3 squared plus 18 minus that 5 that we don't forget about. And then we get our final answer. So the whole point of this is to get to circles. It's a bonus example. Feel free to do this one at home and check your work. You should get 4 times x minus 1 squared minus 21. It's a bonus example, which means it's exciting, right? Bonus. It's fun. Any questions on that before we move on to circles? Yes. Oh, yes, absolutely. That was kind of a preliminary thing. You might have learned this before, but if you didn't, no big deal. You all good? Still working, still working. No questions? Completing the square, yes. Completing the square is on counting, like basically anything you can find. Like Khan Academy basically has everything. So definitely recommend. But circles. So that's what today's class is about. That is a circle. Thank you. Yes, next. No, I'm just kidding. Screw it. There's a trapezoid rule in calculus, and I love doing that on, but it's far funnier because it's calculus. And they are not expecting it. So a circle, we're not really interested in it as a geometric object. We're thinking of it as a two-dimensional object, thinking about it how it appears in the plane. So a circle, of course, is the set of all points that are equidistant from a fixed point called the center. The fixed distance from the center to any point on the curve is called the radius. So we usually label the center as this is H, K. So the center right there, that's the center, H comma K. And then this is the radius right here, radius R. So what is the equation of a circle? It's the set of all the points that satisfy a fixed distance from the center. So that's the reason why we waited until now to talk about it. Instead of talking about it first or whatever, we need to know what the distance formula was. So the distance formula says that the distance between any 2 points is x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. So if I want to find all the points, this would be an arbitrary, don't write this down, but this would be an arbitrary point x comma y. And this is the point of this one you should write down. The center is the point h. Oh, no, we already did. So the radius r is equal to the square root of x minus h quantity squared plus y minus k quantity squared. And so we can square both sides to find a formal equation for it. Algebraically, we say that this is x minus h quantity squared plus y minus k quantity squared is equal to r squared. That's the standard form of a circle, where h comma k is the center. That is the formula for it. And it comes from the distance formula. Given the following circles, identify the center, the radius, and then sketch a graph of the circle. I have to highlight this stuff. So for this first one, graph the following, the equation of the circle. So x minus 3 quantity squared plus y minus 2 quantity squared is equal to 25. So what's the center? Is the center negative 3 comma negative 2, or is the center 3 comma 2? 3 comma 2. So the formula is x minus h. So this is quote unquote x minus h quantity squared and y minus k quantity squared is equal to r squared. So the center is 3 comma 2. It's already in the format. It's already in minus h and minus k. So the h value is just going to be 3 and the k value is going to be 2. And the radius, since r squared is equal to 25, that means that r is equal to 5. Technically speaking, it should be plus or minus 5, right? We take the square root, we have to add the plus or minus. But since we're talking about radii and radius is a distance measurement, distance can't be negative. So we keep just the positive one. So the radius is 5. And how do we graph that? So the fastest way to do it is to plot the center. Remember this. The other thing I mentioned here, I drew it. Did you notice how I drew the center as an open circle? I didn't make it a point because the center is not actually a point on the circle. It is just the center. We use it to graph the circle, but it is not part of the circle. And so that's what we're going to do here. We're gonna draw the center, which is going to be 3 comma 2 right there. And what we're going to do to graph this thing is we're going to go, as we saw before with distance, it's really hard to count 5 units out in any way other than left, right, up, and down, because those ones we can lay on the grid lines. Anything else would be very, very hard to find out where we've gone 5 units. So to create it, if you're drawing it by hand, we'll go out 5 units. So 1, 2, 3, 4, 5 to right there. Plot that point. Same thing on the other side. 1, 2, 3, 4, 5 right there, which is the point negative 2 comma 2. So we have the point 8 comma 2 and negative 2 comma 2. And then we'll do the same thing up and down. 1, 2, 3, 4, 5. Plot that point. The same thing one more time. And therefore we have the points 3 comma 8 and 3 comma negative 3. Now we have 4 points on it and we can finish the graph based on that. Alex will make it a lot easier for us, but since we're graphing it by hand right now, that's the best way to graph it by hand. So then we can just connect them and draw the best circle we can, which for me, I can draw perfect circles. So boom. I know you guys are all impressed with my ability to draw perfect circles. So I'll be here all semester and then I'll be gone. So that's how you draw it. So you draw the center, go out the radius in both directions, up and down, left and right. And then you can connect all 4 of those points. Any questions on that? Yes.
How do we know, some of them, goes later, how we know that's already squared?
Excellent question. So it will all, like if you're given the equation of a circle, that number that on the right hand side where all the variable stuff is on the left and the numbers on the right, that number should always be the r squared based on the formula. The formula, like the right hand side, the number is always going to be squared. This next one was deliberately designed to kind of trick us. Where's the center? Someone said 0, -3, and they're right. The thing is, it's got x squared, which is the same thing as x minus 0 squared. And since we need it to be y minus k squared, we have to rewrite this as y minus -3. We typically don't actually write it down. We just do it in our heads as we get better and better at it. But the fact is, it's not in the right format yet because it has to be y minus a number. So what do? We just double negate it. So y plus 3 is the same thing as subtracting a -3. Same thing. So the center is at 0, -3. And the radius is the square root of 14. We can approximate that if we'd like using our calculator, which is approximately 3.71, 3.74. So to graph this one, it's going to have to be a sketch. It's going to have to be not too perfect. So 0, -3, plot our center. 0, -3 is right there. We'll go out 3 1/4, essentially. Right to about there, plot our point. Same thing up here, 3 1/4, 3 1/4, 3 1/4. And then we'll plot them. Boom, 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 and then connect them with a circle. Not bad, not bad. For estimating 3.75, 3.74. Any questions on that? Well, that's cool if it's given. So we can be given the equation and then graph it, but we can also go backwards. So I thought this was a really fun problem. Oh, that's right. I forgot to mention what general form is. So we'll go back up for just a moment. So up here, this is standard form. And then general form is ax squared plus b y squared plus cx plus dy plus e is equal to 0. So just expanded. It's just you FOIL everything out and bring it all to one side. That's general form. And to go from standard form to general form, you just need to simplify. And to go from general to standard, you got to complete the square. Yes.
Say x plus in general form, is that a one?
X. Next to the X. supposed to be CX. Is that what you're asking? All right. Yes.
We're gonna be working with general form in this unit.
So sometimes circles will be given in general form, but we never really want to deal with them in general form. It's just sometimes they're given like that, and then we have to convert them to standard form. So, general form, good news for us in this first one, the standard form has been given. So, once again, that's going to be, where's the center for this one? -2, 0. Very, very good. And the radius should be 2, because it's already in standard form. So it's already got everything we need. And then the right-hand side is r squared. So r squared is equal to 4, which means that r is equal to 2. To get into general form here, all we need to do is just FOIL it out. So that's going to be x squared plus 4x plus 4 plus y squared is equal to 4. And then we'll just bring everything all to one side. We get x squared plus 4x plus y squared. I mean, you can put the y squared first, I guess, technically speaking. It doesn't really matter as long as it's all just on one side. It's chill. And then subtract the 4s, you get this. Done deal. And then we can graph it. Any questions on that? So once again, we'll graph it. We got -2, 0 as our center. Sorry, I'll try and keep these together. -2, 0 right there. Go out 2 in each direction. Right there, 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 and there. We'll make the tiniest circle we can. Just itty bitty baby circle. There we go. Beautiful. So in case you can't see those points, because they're very hard to see, 0, 0, -2, 2, -4, 0, and -2, -2. All right. That one we've already done. We've already done one of those ones. But what if we're given the other stuff? What if we're given random pieces? How would I find standard form here? Standard form of a circle is, and it's always good to practice, so x minus h quantity squared plus y minus k quantity squared equals r squared. We know that this is our h and this is our k, and this is our r. So we have everything we need. X minus -3, so that's going to be x plus 3 squared, plus y minus -4, so that's y plus 4 quantity squared, is equal to 16. So this is the tricky one. R is equal to, like, it tells me the radius in this situation, so we need to square it. I'm glad someone else, like, it happened to me when I first wrote my notes, when I was recording it, like I was recording a video for it, and I was like, wait, no, wait, and to redo the whole video. And then general form, just simplification. So x squared plus 6x plus 9 plus y squared plus 8y plus 16 equals 16. So at the end of the day, we've got x squared plus 6x plus y squared plus 8y plus 9. So we'll subtract a 16, that'll cancel off the 16s and equals 0. Any questions? Yes.
form that you gave us for general, kind of like contradicts what you said. Is it in order of like the powers? Would it be x squared and then y squared next?
Excellent question. So what's the name again? Bryson. Bryson's asking, so the way I wrote general form is I wrote it as ax squared, by squared, cx, dy, e. So in descending order of degree. Whereas the way I wrote it here is I wrote it in terms of descending powers of each variable separately. So I did the x's first, then the y's, and then the number. It doesn't matter. Alex will accept either. I just decided that I thought like it looked better to write the x's together and the y's together. But that is one of those things in mathematics. I believe some textbooks will say the general form is this. Other textbooks will say that it should be ax squared plus bx plus cy squared plus dy plus e. So like they'll write it differently. It doesn't matter though because of the commutativity of addition. All right. This one here. So it's giving us just the circle. The good news is if you're given the circle, you can find the center and you can find the radius. And then as we saw in the previous example, if you have the center and the radius, you can find standard form and then you can FOIL it out to find general form. So I'd like you guys to go ahead and do that for this one. I'll zoom in for it. Second. So you can see it. Oh, we forgot to graph that one. It's fine. Yeah, you want to graph it at home, be a fun little activity to do. You should get x minus 4 quantity squared plus y minus 5 quantity squared equals 16. So remember your radius is 4, so that means that r squared is 16. And then foiling it out, all of our fun algebra practice, x squared minus 8x plus 16 plus y squared 10y plus 25 equals 16. Simplifying that out, you get x squared minus 8x plus y squared minus 10y equals plus 25 is equal to 0. Any questions on that one? Last one's the trickiest one. What if you're given general form? What if you're given the general form and you need to go to standard and then because looking at it in general form, it's quite difficult to find out where the center and the radius are. So it's best to convert it to standard form first. And we're gonna have to complete the square twice. So need to complete the square on x and y. So I'm just going to rearrange this so that the x terms are together and the y terms are together. That's another reason why I like it to do it that version instead of the way that our book describes general form. So this is x squared minus 12x plus y squared plus 2y plus 28 is equal to 0. So luckily for us, if you're looking at each separate set for completing the square, both times the leading coefficient is 1. So we don't need to worry about factoring or anything like that. We're okay. So for the x squared minus 12x, half the b term would be negative 6. Squaring that would be positive 36. So it's going to become x squared minus 12x plus 36 minus 36 plus y squared plus 2y. Half the b term for y would be 1. Squaring it would be 1 again. So plus 1 minus 1. Then plus that 28 equals 0. Zoom in just a little bit so you can see it easy. X squared minus 12x plus 36 and then minus 36 because the b over 2 would be negative 6. Squaring that gives 36. Same thing for the y's. And then we've got the whole point of that is that this becomes a perfect square trinomial. This becomes x minus 6 squared. And this becomes y plus 1 squared. But we still got that minus 36, that minus 1, and that 28 that need to be dealt with, which I believe is 9, right? Negative 9? Yeah. Yeah, negative 9. So this becomes x minus 6 squared plus y plus 1 squared minus 9 equals 0, which gives us the standard form that we want, which is x minus 6 quantity squared plus y plus 1 quantity squared is equal to 9. Thereby telling us that our center is, take a second, don't answer it for everybody. So the format is x minus h squared plus y minus k squared. So the center should be 6 comma negative 1. And the radius should be 3. Any questions on that? Yes.
You got negative 9.
From doing all the so excellent question. So that's going to be from, let's use brown, combining this and these two. So negative 36 minus 1, that's negative 37 plus 28 should give me negative 9. And then just in the interest of time, I'm going to skip graphing it, but I think we kind of get the vibe for it. All right. But so this is a really fun problem to me. I put a lot of time trying to make this one fun. I hope you enjoyed it. But we'll move on to some interesting ones, right? How many? We got 2 more. Oh dang, we're on track. We're only a slight bit behind. So find the equation of a circle in standard form with center 3 comma negative 3 comma 5 and contains the point negative 2 comma 2. So, well, I know standard form once again is x minus h quantity squared plus y minus k quantity squared equals r squared. Now they gave me the center. They gave me 3 comma 5. So I know that h is equal to 3 and k is equal to 5. But what's r? Exactly right. Bryson, right? Bryson said it's going to be the distance between the center and one of the points. That's the definition of the circle is all the points that are equidistant from that center. So if I know one of the points, so we got 3 comma 5 is right there. And we know it contains the point negative 2 comma 2. We can draw the circle based off of that. And we can find out this distance. This is the radius. So we'll just call this point x1, y1, and this x2, y2. And so r is going to equal the distance here, which is the square root of x sub 2, so negative 2 minus 3 quantity squared, plus y sub 2, so 2 minus 5 quantity squared, which is going to equal the square root of, let's see here, 25 plus 9 is 34. Right? 25 plus 9 is 34. Yes. So that means that the equation is x minus 3 quantity squared plus y minus 5 quantity squared is equal to the square root of 34 squared, or preferably x minus 3 squared plus y minus 5 quantity squared is equal to 34. Either way would be fine on an exam or a quiz. If Alex were to mark you down for writing the square root of negative 30, the square root of 34 squared, let me know and I'll give you full credit back. It just looks prettier to write it with the but it's the whole number instead of the square root, but it's okay either way. Any questions on that? All right. Love this one. Love this one. This one's my favorite problem. This section. Got to highlight my examples. Wait, does that say example 1.2.5? Oh no, it's a typo. Please forgive me. Find the equation of a circle in standard form with the endpoints of a diameter, -4, 4, and 0, -2. So I've deliberately given us a graphing piece to help us visualize this. It gives us 2 points on the end of a diameter. So -4, 4 is right there. And 0, -2 is right there. And so we have a circle created from those 2 points. So, but in order to create a circle's equation, we need the radius and we need the center. How can we find the center? Exactly right. I was like someone else raised that. I want to make sure he was like agreeing with you. Yes. Find the midpoint. To find the center, calculate the midpoint. So we'll call this one x sub 1, y sub 1, and this x sub 2, y sub 2. So the center, in this case, is going to be the midpoint, which will be the average of the x coordinates, comma, average of the y coordinates. So it's not going to be x1 minus x sub 2. It's x sub 1 plus x sub 2. Don't make that mistake. So -4 plus 0 divided by 2, and then 4 plus -2 divided by 2, which is -2, 1. And let's see. -2, 1, that looks to be right about in the center of those two. Yay. And then we can, now that we found the center, there are 2 ways we can calculate the radius. What's one way to calculate the radius? Sorry, you already said it, so.
Find the distance between the 2 diameter endpoints and then divide that by 2.
Exactly right. That would be the, if you didn't want to utilize your center in case you weren't certain whether or not you got it right, you could find the distance of the diameter. And since the diameter is double the radius, just have it and that will give you the distance. Or you could just take the center now that you found it and use either one of the points and you'll get the radius. However you want to do it, looking at the time, we don't have enough time to do it, but we will pick up next time with that and call it good. If you guys have any questions, please feel free to email me. Please make sure to complete that syllabus quiz by Wednesday at 2 p.m. I'll remind you guys that time too as well, but ideally get it done earlier. If questions, feel free to email me. Otherwise, you guys have a great rest of your day, and I'll see you on Wednesday.